Hello and good afternoon, everyone. I welcome you all to India's largest e-learning platform, Unacademy, and welcome you all to GATE Conqueror channel. We're into Antennas CTQ series, Concepts Through Questions series. Let us learn the concepts through questions. Very important series or a very important way of learning concepts so that you can cover both questions as well as concepts. CTQ series part 3. How are you all, dear? Before we start the class, let me introduce myself. I am G C Reddy, having 15 plus years of experience in teaching, guiding and mentoring GATE and ESE aspirants. I work as motivational speaker pan-India from the past 12 years, expert in field theory and communications. And, this is the official link where you can join us on Telegram, dear. This is where you can join us on Telegram. The advantage of joining us on Telegram is you'll get a personal level support from all the GATE Conqueror team, all the faculties of the GATE Conqueror team, dear. And we'll be more than happy to guide you in your competitive exam preparation. Unacademy offers two paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the face time of legendary faculties in the form of live classes, weekly test, structured courses, unlimited access, rank improvement batches and crash courses. In Iconic, we have all these features. Along with that, we have a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts, preparatory study material, personalized test analysis, study booster sessions and customized study planner. And your personal coach will be helping you out in you designing a customized study planner for you people. Whether you go for Plus subscription or Iconic subscription, I recommend you to go for a no cost EMI. Total cost will be divided by number of months. Very much student friendly, and you can use our code KNR10 to get extra 10% off, dear. You can apply it for both Plus and Iconic subscriptions. Iconic subscription, you get 1:1 live mentoring, increasing your chance of getting a top rank. This comeback for GATE and ESE aspirants. It's a live quiz competition with 20 questions will be asked. 60 minutes will be given. It's conducted this April 10, 11 a.m. Separate paper will be designed for mechanical, civil, electrical, EC and CSIT. Those who score a rank from 1 to 3 will be awarded with 100% scholarship or free subscription. 4 to 10, 75% scholarship. 11 to 50 rank, 50% scholarship. And 51 to 100, 25% scholarship. And you can enroll yourself. Enrollment is free, dear. You can enroll using our code KNR10. The best study material is here for GATE and ESE. That's a good thing. The material is curated under the guidance of top educators. We have comprehensive syllabus coverage, solved examples to build problem solving skills, chapter wise practice questions. It's accessible anywhere and anytime and available for both Plus and Iconic learners. You can subscribe now by using the code KNR10. This is GATE 2022 top 10 rankers here. In top 10 we have 3 All India rank 1s. It speaks volumes about the quality of education that we provide at Unacademy. Right now the price has been increased by 10%. But do not worry dear, you can beat this 10% prices. By using the code KNR10. If you have any doubts, you can get in touch with our counselor. If you are having any doubts in your preparation journey, subscription or latest offers, this is a number where you can dial to our counselor. It will definitely help you in guiding you for a better future. This Unacademy Ask a Doubt feature, which is now available for both in website and app. You can ask unlimited number of doubts. You can ask 3 doubts at a time. Get the solution in your preferred language. It's also very easy to ask your doubt. Just click crop and submit. This is a special class features which includes interactive live classes, polls for the learners, raise the hand option. You never miss a class when the notification is on. You can download the lecture notes when the class is done, and you can access anytime and anywhere. Introducing community where you never miss any update from your favorite educator. You can get the session notes and practice material, and also you can share your feedback directly with the educator via polls. These are the new batches dear. Resilience droppers batch for GATE 2023 will start from March 30 for electrical explained bilingual. Resilience GATE 2023 for EC explained bilingual. Evolve GATE 2023 for electrical explained bilingual. Evolve GATE 2023 for electrical explained bilingual. Ascend GATE 2024 for electrical explained bilingual. Ascend GATE 2024 for electrical explained bilingual. These are the new batches dear. In all of these batches, you can use our team code KNR10 to avail extra 10% off dear. We are into antennas, concepts through question series. These antennas are part of EMFT subject. This EMFT contains 5 modules. Module 1 is elements of EMF theory, which is common for both EC and electrical. For electrical it is complete syllabus, and for EC it's one of the module out of 5. Already a playlist has been created on this module with 40 videos and 50 hours of content. Good evening, Bhaskar. Module 2 EM wave propagation. On this too, we created a playlist. With 15 videos and 30 hours of content. Module 3 is transmission lines will start. Module 4 is waveguides. Module 5 is optical fiber communication and antennas. And for these antennas, separate playlist is created in the name of Antennas Maha Marathon series. 18 videos, 38 hours of content. So on EMFT, right now on the GATE Conqueror channel, there are 3 playlists. One is on module 1, 50 hours playlist is available. Module 2, 30 hours is available. Module 5, 38 hours of content is available. It makes total of 118 hours of content already available for EMFT. And these antennas were dealt in detail. Antennas Mahamarathon series. Three faculties are for EC. In 4 new lecturers, Bhaskar, 3 faculties are from ECE, core EC. Need not worry. The good days are back. We'll have some excellent content here. And as you know, on one side, I'm also doing my best to cover most of the syllabi. We'll start communications also very soon here. Once EMFT is done, we'll start communications also very soon. So we are into antennas concept through question series. What we had covered, antennas Mahamarathon series. What we had covered is basic terminology of antennas, radiation mechanism of antennas. Radiation mechanism states that L into di by dt is equal to Q into acceleration. The condition for radiation. We have seen the radiation. Radiation by single wire. Two wire. And dipole antennas. Then we have seen the radiation pattern of the antenna. Radiation pattern is a three-dimensional diagram or three-dimensional figure which explains about the radiation of a given antenna. This radiation pattern we are seeing terms like main lobe, side lobe, nulls, back lobe, beam width between first nulls, half power beam width, beam area, then we discuss radiation parameters of the antenna. Which include gain, directive gain, power gain, directivity, efficiency, and radiation resistance. These are all the radiation parameters of the antenna that we have discussed. Then we have discussed antenna arrays. In arrays, we have seen two element arrays. Analyze the field pattern for all the 5 cases. Then we have seen n element arrays. We have seen n element arrays. In n element arrays, we have seen broadside array and end-to-fired array, n element case. We have seen spatial arrays. Under spatial arrays, we have seen end-to-fired array, increased directivity. It's also called as Hansen and Woodyard array, which increases your directivity here. And what he proposes, instead of maintaining alpha is minus beta d, we need to maintain alpha is minus beta d minus pi by n, which increases the directivity by value of 78.9%. And under special arrays, we had also seen binomial arrays. The feeding of the antennas elements is done or decided by the binomial series. The coefficients of the binomial series. These are two special arrays here, and these binomial arrays are famous for tracking applications where there are no side lobes. Of course, it will suppress the side lobes, but at the cost of directivity. And then we are seeing the 7 sister antennas. In 7 sisters, we are seeing folded dipole antenna, Yagi-Uda antenna, helical antenna, microstrip array antenna, horn antenna, parabolic reflector antenna, and lens antennas. These are the 7 sisters that we have discussed. Other than this, we have discussed about resonant and non-resonant antennas. Resonant, we have seen monopole, dipole. Non-resonant, we've seen antennas like V antenna, inverted V antenna, and rhombic antennas. Besides this, we've also seen antenna measurements. In antenna measurements, we have seen radiation pattern measurement, basic setup required for radiation pattern measurement. Then we have seen measurement of gain, and directivity. Measurement of gain can be done in 2 ways. Two antenna method or measurement of absolute gain. By using 2 antennas or 2 identical antennas. This is the second method. Or we can do this through the first method. The 3 antennas are used. Then we can derive the gain of the antenna from this. That's measurement of gain here. Directivity, what's the formula? Yes, of course. Of course, here I'll explain communication. Then measurement of directivity. Yes, Srikanth, hello. Directivity, as you know, is 5 max by 5 AV. Directivity, as you know, is 5 max by 5 AV. 5 max by 5 AV is WR by 4 pi. 4 pi times of 5 max by WR. Directivity is 4 pi times of 5 max. Double integral of phi of d omega. If phi is radiation intensity, d omega is sin theta d theta d phi. It's 4 pi times of phi max, theta 0 to pi, phi 0 to 2 pi, 5 times of sin theta d theta d phi. Very clearly, evaluation of directivity involves double integral. Therefore, general methods are not applicable here. That's the reason why we go for graphical numerical methods. In graphical numerical methods, we try to keep one variable constant. There are two types in which it is done. One is orange slice method. Phi is constant. The other is conical cut method. Theta is constant. That is what we have seen antenna measurements. And in wave propagation, we are seeing principal modes of propagation. Which is ground wave propagation, sky wave propagation, and space wave propagation. These are principal modes of propagation here. Besides this, we also have special modes of propagation, which includes scatter propagation, under scatter propagation we have tropospheric scatter, ionospheric scatter, that's about the special modes. Tropospheric scatter and ionospheric scatter. Besides that, we have duct propagation. Besides these, we have derived the derivation for refractive index of ionosphere, sin I by sin R, under root of 81 Nm by F square. That is what we have derived, refractive index of ionosphere. Mechanism of radio waves bending by ionosphere, virtual height, critical frequency, maximum usable frequency, optimum working frequency, and of course penetration depth, analysis of this. Besides this, we have seen ionospheric abnormalities, in which we have discussed about 10 points. Then we have derived the range of space wave propagation, which is 3.57 into under root HD, under root HR, kilometers, HD and HR, height of transmitter and height of receiver measured in meters. The approximated formula for range is 4 times of under root HD plus under root HR kilometers. And also we derived the derivation for received electric field strength in space waves. ER is equal to 88 root P HD HR by lambda D square. Besides this, we have seen topics like fading and path loss calculation. Path loss calculation formula 32.45, 20 log to base 10, distance in kilometers, 20 log to base 10, frequency in megahertz. That is what we discussed. Antennas Mahamarathon here. With this note, we'll start the CTQ concept through questions. Hello, Srikanth. How are you? Yes, please let me know. How are you? Any doubts? Any doubts you can ask dear. So we are into antennas concept through question series. We've done some wonderful problems previously and analyzed some concepts. We'll do the same today also. So, kindly answer these questions, dear. What is the answer? What is the answer? Efficiency of an antenna ranges from 0 to 1, ranges from 1 to infinity, equals to GP by GD, or equals to GD by GP. Is there anyone? Anyone? Efficiency of an antenna. Efficiency of an antenna, eta, is given as ratio of power gain to directivity gain, or power gain to directive gain, GP by GD. It is defined as the ratio of radiated power to total input power. We all know that total input power is radiated power plus lost power. For example, if you take an antenna, the input power to the antenna is given as 10 watt. Total input power is 10 watt, of which, for example, radiated power is 8 watt and lost power is 2 watt. That means what? Total input power is radiated power plus loss power. Radiated power is given by I square RR. What is RR dear? What is RR there? What is RR? What is RR? RR refers to radiation resistance. RR refers to radiation resistance. Therefore, I square RR plus I square RL. Taking I square common and cancel out. Efficiency formula RR by RR plus RL. And efficiency can be between 0 to 1. 1 implies 100% efficiency. So the range is 0 to 1. Efficiency ranges from 0 to 1. First one. 1 to infinity is wrong. The ratio of GP to GD, power gain to derivative gain. This is correct. GD to GP is false. 1 and 3. Option A is the answer. These are the other formulas also. And radiation resistance of a half wave dipole. Half wave dipole is nothing but a dipole whose total length is equal to lambda by 2. Which is half wave dipole. Radiation resistance is 73 ohm. 36.5 ohm. Quarter wave monopole. For a dipole, whose length is in between whose length is less than lambda by 2, greater than or equal to lambda by 10. For this case, radiation resistance 80 pi square dl by lambda whole square. Monopole, length is lambda by 4, greater than or equal to lambda by 10. For that, radiation resistance 40 pi square dl by lambda whole square. Then for a dipole, length is less than lambda by 10. It's 20 pi square into dl by lambda whole square. Monopole, length is less than lambda by 10. Radiation is 10 pi square into dl by lambda whole square. For loop antenna, radiation resistance is 31,200. Na by lambda square whole square. That is for loop antenna dear. So now if you see 1 and 3 are correct. So question number 1 option is the answer. Is that clear? Next question. On a two-wire transmission line, current of two adjacent half cycles are in phase. Current of two adjacent half cycles out of phase by 180. Current at any instant of time on two wires are in phase. Current at any instant of time on two wires are out of phase by 180. This is the correct options there. Try and choose the correct options. Anyone, what is the answer? What's the answer here? A two-wire transmission line if you consider this as a source, this is source, two-wire transmission line, this two-wire transmission line, this positive, this is negative. On a two-wire transmission line, current of two adjacent half cycles. This is one half cycle, this is one more half cycle. It goes on. Here the negative will start, then the positive, then the negative, and it goes on. The current of two adjacent half cycles are in phase. These are two adjacent half cycles. Is the current in phase? No, they are out of phase by 180. This statement is wrong. Current of two adjacent half cycles are out of phase by 180. True. This statement is true. Current at any instant of time on two wires are in phase. At any instant of time, if you want to take the current value, this is the current value. At any instant of time, this is 270 here and this is 90 here. They are out of phase by 180. At any instant of time, they are out of phase by 180. In phase is wrong, of course. In phase is wrong, out of phase by 180 is correct. Current of two adjacent half cycles are out of phase by 180. Current at any instant of time on two wires are out of phase by 180. 2 and 4 are correct. Option D is the answer. Clear? Next question. An antenna has operating wavelength of 10 meter. An antenna of length 5 meter will have the same radiation pattern that of antenna with the length of dash meter. Lambda is 10 meter, 5 meter means lambda by 2. Length of lambda by 2. An antenna with length of lambda by 2 will have same radiation pattern. The current distribution the maximum radiation like this. An antenna has operating wavelength of 10 meter, lambda is 10 meter. Antenna has a length of 5 meter, that is lambda by 2. We'll have the same radiation pattern of that of antenna of dash length. For example, if you take 10 meter, if you take 10 meter, these currents oppose each other. Meaning total radiation 0. This 5 meter, this 5 meter. 10 meter is not correct. 15. In 15, 5, 5 and 5. They cancel it out. Length of 15 meter will have same radiation as that of length of 5 meter. Okay. 5 meter and 15 meter having same radiation. If you take 20 meter also, it does not work. Why? Because the 4 half cycles like this. How is the current? The opposite nature like this. The strike of 20 meter is not correct answer. 10 meter is also not correct. 0 radiation there. 15 meter and 5 meter will have same radiation. Five meter and 15 meter will have same radiation. Question number 3. Option B is the answer. Identify the true statements. Straight conductor fed with the DC current. Straight conductor fed with the DC current radiates. For an antenna to radiate here, the basic condition is L into di by dt must be equal to Q into acceleration. Only then the antenna can radiate. Here if I consider a straight conductor fed with the DC current means there is no time varying current here. And DC current has uniform velocity, therefore no acceleration or deceleration of charges. Thereby a DC current fed to a straight conductor will not radiate. A straight conductor fed with the AC current, a straight conductor fed with the AC current, of course will it radiate. Straight conductor fed with AC current radiates. A curved conductor fed with DC current. If you take curved conductor also and if you feed a DC, because of this slope there will be acceleration and deceleration of charges, which can be used for making the antenna to radiate. So a curved conductor fed with DC current radiates, yes. Because if I apply the DC current to a curved conductor, there will be acceleration and deceleration of charges, which is important for us. Curved conductor with the DC current, as I told you, curved conductor with the DC current radiates, true. A curved conductor fed with AC current radiates, yes, it's also true. 2, 3, 4. Option B is the answer. In a given radiation pattern of antenna, if half power beam width is 40 degrees and FNBW is twice of half power beam width, it must be 80 degrees, dear. Option C is the answer. Is that clear? A null, of course it is null, that occurs between main lobe and side lobe is called as, draw a radiation pattern of an antenna, draw a radiation pattern of an antenna, the main lobe, the side lobes, the back lobe, a null that occurs between the main lobe and the side lobe. These are side lobes. A null that is occurring between the main lobe and the side lobe is called as first null. And the angle between these two first nulls will be exactly equal to this beam area. A null that occurs between the main lobe and the side lobe is called as first null. Option C is the answer. In normalized power pattern, FNBW value Pn of theta is, as the name indicates, normalized power pattern. The severe. In normalized power pattern at FNBW, the value of Pn of theta is, in normalized power pattern means maximum value Pn of theta is 1. At FNBW, beam between first nulls, the value of Pn of theta is, in the position of nulls, the power is 0. The option is the answer. In normalized power pattern at half power beam width, in normalized power pattern that is Pn of theta is 1. The value of Pn of theta is, for half power beam width, 3 dB down point, power Pn of theta is 1 by 2. Option C is the answer. In normalized field pattern at FNBW, the value of En of theta is, normalized field pattern at FNBW, is equal to the 2 times of theta Pn of theta is 0. In normalized field pattern, En of theta is 1 here. And P is proportional to E square, point at which the power will be half. E value will be 1 by root 2. 0.707. Normalized field pattern at FNBW, the value of En of theta is, at FNBW, the value of En of theta is 0. In normalized field pattern at half power beam width, value of Pn of theta is, at half power beam width, the value of power Pn of theta is 1 by 2. Now Pn of theta is proportional to En square of theta. At half power beam width, Pn of theta is 1 by 2. Normalized field pattern, I want to know what is the value of En of theta. Pn of theta is 1 by 2. En square of theta is 1 by 2. En of theta is 1 by root 2. Option B is the answer. If the power of the main lobe is 100 watt, the power of the main lobe is 100 watt, side lobe ratio or side lobe level is minus 20 dB, side lobe power is dash watt. Very important question here. Okay, try to note down this question here. Next class, I'll be asking you your solution. The power in main lobe is 100 watts, side lobe ratio is minus 20 dB. Side lobe power is Thank you all dear for joining. Have a great day.